All right, chapter 1. Let's see, following chapter P, where we just did, it's got some basic algebra skills just to kind of brush up to get ready for a course in functions. It's time to dive deeper. We'll kind of go one function type at a time, and linear is always a great place to start. So that's for the most part what you're going to see in chapter 1. We're going to split it into two parts, 1A and 1B. I think as far as the learning targets go, 1A is 1.1, 1.2, 1.3, and 1.7. And that's all linear. And then 4, 5, and 6 we'll get into quadratics. So there you go. This is really chapter 1A. On that note, let's dive in. A solution point to an equation when substituted in for x and y makes... Ran out of room over there. Can't see the end of the sentence. It's no good. All right, there you go. There we go. Makes a true statement. Okay, that's a good point to be really clear on, that you have like a point and you substitute it in, which is what we're going to do down here, right, in part A. $13 is my y value. Obviously, I'm using this linear equation right here just to kind of brush up on the lines a little bit, because you're going to see them a lot. There's your slope. There's your y-intercept. All right, so I put in 2 for x, and now it just becomes a matter of, is this true or not? Nothing to simplify on the left side. 10 times 2 plus 7, I believe that's 27. And last I checked, 13 and 27 not equal. Hard no on that one. Hard no. There's really no such thing as a soft no on checking for solution points. It is or it isn't, right? So if you had plotted that graph, you would see, I should say plotted that equation, right? In other words, use it to make a graph. It does not go through the point 213. Okay, that point's not on the line. -3 in for y. -1 in for x. We'll test to see if this is a solution. -10 plus 7. There you go. Is that a solution point? Yes, it is, right? Easy enough. If it works, that point is a solution, it would be on its graph. All right, a couple more lines. I'll really zoom in on this one in a second. Okay, a couple different ways you could do this, right? If you want to make a table, that's not a bad idea. You don't need to on a line like this. I'll show you a way in a second here how to not do it. If you were to do that, I would pick a handful of points, some of which are positive, some of which are negative, and you would plug them in, right? And by the way, for part A, that's the equation I'm using. You get -8, you get -6, -4, -2, and 0, right? Just fill out a table of like 5 solution points, you plot the points, and there you go, right? You don't need to, okay? The only thing that we'll need to talk about more, like with making a table of solution points, because that'll be a thing you'll have to do. The more complicated the function gets, like the x values that you pick, right? I picked nice ones here that just, they gave me whole numbers as answers, which I could tell was going to happen. If you had gotten decimals as answers for your y values, that's no big deal, all right? But with a line, a couple negatives, 0, and a couple positives, that'll work just fine. If you had a slightly more complicated equation, the x values you pick can be a big deal. So kind of hold the phone a little bit on picking x values to make a table, because that's really the key. You gotta pick 5 good values that are going to give you a good visual of the graph. All right. Now, again, for now we're sticking with lines, so I'm going to zoom in here. Kind of show you another approach you could take. Okay. You can always start with the y-intercept. That's right here at -4. graph has to go through there. And then I can use the slope, okay? This slope would say, all right, for every 2 units you go up, it's got a positive slope, go to the right 3, right? This is change in y over change in x. So I go up 2 over 3. Whoops. Be cautious for this kind of thing. I am pretty sure that was that backwards? No, that was right, sorry. I thought I had flipped the x and y, which you should be careful of because that's easy to do. Up 2 to the right 3, and then just keep that going. Up 2. That's not what I wanted. Sorry about that. There we go. 1, 2, 3. Now I'm switching it up and I'm going down 2 over 3, and eventually, I mean, there I have 5, right? And that's actually, I think, the same 5 points I put in the table, right? And you can see, you get a nice looking line. So I carefully connect my points. Throw an arrow on that. Arrow on that. Boom. There we go. There's a good looking line, okay? Y-intercept of -4, slope of 2/3. So you can, if you identify the y-intercept, then you can just kind of use the slope to plot other points. That's a great way to do it. It's kind of like you just bypass the process of making the table, which is okay. All right, let's go to part B. Let's do another one. I'm not going to make any table on this one. I think you get the idea there that pick some x values, plug them in. I'm just going to do the slope thing here. Okay. And I'm going to move this around a little bit. All right, so I'm going to use the slope and the y-intercept. It's good to have it in slope-intercept form. So over here, I'm going to take away 4x. 3 minus 4x. All right. Now the order here kind of switched. Just so you know, that 3 is your y-intercept. That -4 is your slope, right? Now, as we're going to use that, think of it as -4 over 1, right? So I'm thinking you go down 4, right 1. All right, and it's all going to start at 3, right here. There's the y-intercept. The line has to go through that point. I go down 4 to the right 1. There's another point. Sorry, the graph is a little bit blurry, just because I'm zoomed in so close. The graph is labeled with a scale factor of 1, in case that was hard to see. That's all that's going on. And over 1. There we go. I can keep going here. Go to the left 1 and then go up 4. Let's see here, over 1. 1, 2, 3, up to here. Call me an overachiever. I put 6 points on there. You're welcome for going above and beyond, putting on 6 points instead of 5. You're sitting there thinking, dude, like I care. You did 6 instead of 5. Good for you. I'm proud of myself, though. Though I didn't exactly draw on the straightest of lines, but you'll notice my sketches and my graphs, they're hit or miss. My first one was pretty good. This one, yeah, okay, roughly works. Got a y-intercept of 3, slope of -4. We'll call it good, all right? I think in terms of using the y-intercept and slope, you get the idea, okay? All right, let's talk intercepts. That's always a good thing to take a peek on. All right, notice a couple non-linear graphs. Again, I said 1A is mostly linear. It is, okay? I'm dabbling a little bit here, but as far as the algebra, we'll really only dive into linear graphs in chapter 1A, right? I'm not, like, these kinds of functions are sort of common in 1B, so I don't mind you seeing them. Above just has descriptions of intercepts, right? X and Y. Just keep your axis straight. There's your Y axis. There's your X. It can vary from function to function how many they have, all right? Now, one way to do it is to just observe. Right? That's all that's going on down here. Here's a cubic graph. Zero, 1, that would be your y-intercept. That point is right there. And this is not a bad way to do it. If you have a graph and like the graph is good and readable, you know, you can just observe intercepts from the graph. It's like the easiest way to do it. The x-intercept is right there, right? So it's crossing the x-axis at -1, the y-axis at +1, okay? Notice the pattern here that your x and your y-intercept, okay, we'll talk about this more in 1.2 actually, that it had x equals 0. That's always the case. X is always 0 at your y-intercept, and for your x, would you go ahead and look at that, y is 0. In fact, I want to show you that here, that again, you could just observe right here and look at that and see, all right, if I'm doing my y-intercept, right, that looks to be the point 0, 0. And then for your x-intercept, looks like 0, 0, and then -5, 0. But I do want to show you here, you know, how to get these 2 points, okay? So this is specifically for an x-intercept, right? Now, again, we'll build on this, but, you know, I'm not going to take you through the y-intercept right now, but for this equation, you just have to plug in 0, right, to get the y-intercept. For the x, set y equal to 0 and solve. Okay, so that would basically mean you would get your 2 solutions for the x-intercepts from that, okay? Now, how hard that's going to be to solve and how many solutions you're going to get, it depends on what your function is. This one's a little bit more complicated. It's a quadratic, and it has 2, okay? It's going to require a little bit of factoring. For example, I would take out, negative x, right? Which would leave me with x plus 5. So back in chapter P, our prerequisite, we called this common factoring. I looked at these 2 terms and said, hey, they both have a negative sign, they both have an x. Okay, so double check that. If I were to FOIL the negative x squared, I would get back to what I had. And from here, I can solve each factor separately, and that was really the point in doing it in the first place. 0 equals negative x. And then down here, 0 equals x plus 5. Technically right here, if you want to solve it, divide both sides by -1. Okay, x equals 0, which we already knew that was one of our solution. What are we expecting to get from the other? Should be -5. Take away 5. Take away 5. X equals -5. Okay? I know that's a little bit much. In 1.2, we'll come back to that and really dive into this whole intercepts thing, how to get them using algebra instead of just looking at a graph. The big thing for now in 1.1, if you want to get them off a graph, be my guest. Just look at them and observe them. Sometimes if they're not whole numbers, it's not really like easy or clear to see them. So keep that in mind. Okay, that's all for 1.1. As always, if you have questions on stuff, let me know. Be sure to be in contact, and let's get those questions taken care of.